Yeah, so again, just kind of kick off, background about yourself, how you got into it exactly like that, and then how you got into the company, that sort of thing, how it started up, but cool.
Okay, well, so it started, we were running as consultants advising architects principally on energy efficiency and renewable energy in buildings, and spotted there was a niche in the market, there was a gap, there was a lack of a product that would work well on buildings or adjacent to them, where you've got turbulent winds, but where you've also got you're much closer to people's bedrooms or very noise sensitive areas, so you've got to make something that's quiet. And those are the two things that's really driven the product, something that works well in turbulent winds, but quietly and efficiently.
So what actually happened from that? How did it all kick off? Where did you go from there?
So yeah, we were originally looking for a product, an existing product, but if there wasn't one there, we had a brainstorming session and came up with these ideas, and it started out quite gradually, testing out a few things. It started out initially very Heath Robinson. We spent quite a few weeks running up and down a disused runway with a pickup truck and different bits of turbines, different shapes, different geometries, blade profiles, on a scaffold rig on the back of a pickup truck. It was great fun, but it was actually very informative, and it sort of launched the way to actually getting much better analytical models to simulate all the aerodynamics and the performance of the turbine, and then to have the confidence to invest in what, for the shape of the turbine, is quite an expensive process of prototyping blades of this shape and size.
So did you get investment then, or what did you find?
We funded initially ourselves from our consultancy work. We had some help from Smart Awards and other government supports, and then we've had some very supportive investors once we'd sort of proven the first concept. So
how long ago was that?
It was 2004 that we first had the idea and begun to take shape. We got the first full-scale one spinning in 2006, and it's been ramping up and stabilising production and setting up assembly facilities on that side since then.
So please tell us more about this turbine then.
The concept of vertical axis turbine is not ours, it's not new, it's been around. A Frenchman in the 1930s, Darius, got this idea of the lift type vertical axis turbine. He didn't actually, as far as I'm aware, he really didn't get it working properly at the time, partly perhaps materials and also control systems that weren't there, but now we've got kind of the latest composite materials, so we can make this thing strong and light, which is key to making it efficient. We can make the shapes that we want, and we can control it well and keep it sitting at its optimum performance through the wind conditions. The helical catenary structure is driven, initially it was about sort of vibration. We wanted something that was going to give a seamless driving force from the aerodynamics into the generator and not going to vibrate the structure that it's mounted on much, which is an issue with some of the straight-bladed vertical axis turbines. But it does complicate the manufacturing. It makes quite a hard shape to make, and it's a hard shape to analyse. So it's those progresses in analysis, materials and technology that has enabled us to do this really.
So most people are used to the horizontal axis, 3 blades spinning at the side of the road or wherever it is. How does yours compare to that with efficiency? Noise, as you said, was a major issue. How does it compare?
The big turbines, large scale, megawatt things, have spent so much time and money now optimising their aerodynamics that they are performing better than we are on aerodynamics. But we're absolutely comparable with similar scale horizontal axis turbines in efficiency. What's key is that we maintain that efficiency in turbulent winds.
Right, okay.
Horizontal axis turbines, unfortunately, can't turn to track changing in direction fast enough in these sort of scenarios. So if you're on top of a hilltop, it's a very appropriate technology, thoroughly support that. But if you're sitting in very turbulent winds, you lose, by our calculations, up to about 40% of your energy yield of what is theoretically there in the wind, because your horizontal axis turbine can't turn fast enough to capture that energy.
So turbulent winds anywhere in a city where there's lots of high buildings, places like that, yeah.
Whereas we're very pleased, confident with our measurements that actually we maintain or slightly improve our position and our energy yield in turbulent conditions.
How is it compared to people like, Flow Design in California then, who've got almost these jet engine-like structures as well? Is it similar issues there?
Actually, I don't know the details of their design, I'm afraid.
It's really quite cool actually. I don't know how they do it, but it's the way they force air into the fan. It makes it cylindrical, the air going round. It'd be cool to look into though.
Okay.
They're about 1/3 of the diameter or something, but it's again still horizontal axis.
So they'll have the same issues of turning to face the wind. Maybe appropriate for a very sort of consistent wind direction site. There are sort of fundamental laws of physics that govern how much energy you can extract from the wind, and in a way, the schemes with a shroud or a venturi that funnel and focus the air onto a smaller rotor might mean your rotor is much smaller, but you still have to have a structure which covers the same large search area. And there have been numerous sort of prototypes or ideas about that for conventional horizontal axis turbines over the years. I'm not aware of any that have really taken off and done well though.
So you say yours are generally now in very much built up areas. You know, where are they? I see you got them out in Germany. Is it just now?
We've got a couple in Germany, mostly in the UK where we started off. But yes, I'm in Holland and Germany and Australia. So beginning to branch out overseas. Predominantly, we're focused on urban areas. It is still very sensitive to the wind speeds, and you do need to find the right location in any country. The wind speeds will vary across the terrain considerably, and so I think perhaps being branded as an urban product, generally right in the heart of centres is the wind is too light. But around the periphery you still definitely have quite turbulent winds, but you also have energy demands, and that's probably where our key market is.
I saw on your website as well how you've very much got the kind of small to mid-size ones, but you've also got the major, much larger ones in looking into as well in research and development.
We're developing a larger product yet. It's not on the market yet, but we hope it won't be.
What sort of time do you think it will take before you get there?
I hope, well, to develop and test and validate something like this is still a minimum of about 2 years to get it out there.
Okay. And manufacturing-wise, are they built in the UK? Are they built in China? Is it a different process than the standard ones? Could you talk more about that?
Built in the UK. We source parts. We get a few parts in from Europe, and they're all assembled in our facility in Wales and tested there. The processes are relatively standard composite manufacturing techniques used in automotive, aircraft industries, aerospace, sort of similar small-scale production.
With the logistics as well, I presume because these don't have the huge blades on them, they're far easier to actually get to the location from the manufacturing site as well.
At the moment it's still just small enough to fit on the back of a load loader, or the back of a truck. So ground transport's fine. They do fit in a shipping container as well. But we're still doing some work actually optimising how many you can pack in and to sort them out for higher volume overseas installations.
Obviously you mentioned that you're going for the larger turbines as well, but looking 5 to 10 years down the line, where do you see the company?
Initially we're really focusing on increasing the volume of the current product and its sort of the 12 metre version, its larger brother. I think our key market is always going to be, our key focus is going to be on sites where turbulent wind is prevalent and noise is a key issue. So I don't think we're really going to be making megawatt scale versions of these. We aren't going to be competing with Vestas wind farms or whatever, but I think there is a growing and actually quite a large market in these sort of this size of rotor and in these locations, feeding power directly into the sites where people use it. Microgeneration,
so to speak, yeah. We were talking to Ceres Power actually last week, and it was interesting. We had one guy who was talking about major solar wind farms and saying how he's like, yeah, I don't think they're going to be the future, I think it's going to be microgeneration. Then Ceres Power obviously, we talked to them and he's like, yeah, 20 years ago they said there'll be 3 computers in the world and everyone's got one. We think power's going to be similar, so I presume everyone could have something on top of their house or such like. Could you talk more kind of technically about the swept area and how that affects things as well?
I mean, the basic physics is that the power available to you is directly proportional to the swept area of the turbine, area perpendicular to the wind. So the easiest way to increase your output is to make the thing larger. We have a relatively tall and thin structure which keeps the rotational speed up, which kind of helps the generator efficiency, reduces the torque there.
Now, obviously, you said you got to where you are now by the funds you generate yourself with the consultancy. Moving forward, do you think you need to get more investors on board, or do you think you could do it yourself as well?
Yeah, so we started off ourselves, and we've had some very supportive investors to date, and have continued to have their support. I dare say there'll be more investors in the future. Other interested parties, yes.
With your experience with investors in this sector, do you think, obviously a lot of investors have had experience in other areas like IT, web, places like that, you think with them, some switching over now, they just don't have the expertise to truly understand a clean tech company and the timescales involved?
I think our investors actually have been very pleased with their understanding of the sector and the issues actually of sort of any new product development and the challenges that we face. They are experienced in energy and in clean tech already, so they are familiar with our environment and our challenges.
Now, if you had to give advice to entrepreneurs wanting to get into this clean tech sector as well, what would it be?
Yeah, okay, well I think it's great, it's rewarding, it's very satisfying to see your concept turn and actually see energy coming out of it. I think you should take each step by step, and it's quite tempting to launch in quickly and get your foundations right and then have something good to build on. I think there is support out there, whether it's from the sort of government grants to help things up or from investors who know what they're who know the sector. So it is definitely worth networking out to as many people as you can and tap into the knowledge of people who've been there and done it before. It's very difficult to know exactly which. It's such a rapidly expanding sector with so many different strands going through. It's the scope for lots of innovation in new directions. It's really difficult to really know which is going to take off more than one area or another. I think at the moment it looks like a lot of it is going to have great potential.
Okay then, well, building on that, if you had to pick one clean technology to change the world, what would it be?
Would you like a new one or the existing?
Anyone you like, yeah.
I think I've just said it. I think that's hard. I think there's scope for all of them. I think they have different niches. I think something that can. I hope that we can develop this and then to expand its role and remit right around the world and into new markets. We're quite focused on high value markets at the moment where electricity is relatively expensive. There's all sorts of developing countries where applications would really benefit from improved electricity supply and cheaper electricity supply. And once we get over our cost and volume and we can get the price of the machines down, we can then expand and support a lot of developing countries, I think, as well as large Western economies.
So you think wind turbines are the clean technology that could change the world?
They're not the answer. They're part of it, though.
Part of a bigger picture.
Yeah.
Well, going back to what you were saying before, how you won't be able to take on the megawatt generating guys, you're more focusing on the lower end and microgeneration. How do you think the market will become more fragmented, or how will it evolve over the next 5-10 years? Because it really is in its infancy just now.
I mean, at the moment, I think the technical barriers are relatively few to greatly expanding the microgeneration that exists. If we do get a good growth in technologies, then there will need to be some improvements in grid, and there are some interesting developments in sort of smart grid and grid control and investments there, which will be needed to sort of maximise on the potential for microgeneration. So we will need that support on the infrastructure before too long. I hope we'll be in a position where we're pushing that boundary.
Well, just going back to your actual product itself then, obviously with the standard horizontal axis, ones you can see, you've got the blades at the front, gearbox at the back, fairly simple. With yours, where does all the componentry actually sit? Where do you move the gearbox around to? And is it that causes efficiency, or is it the sheer blades itself?
The blades are very important because the primary thing you've got to deal with is capturing energy from the wind, and to do that efficiently you get the maximum amount of shaft power into the system. We have a direct drive system, so no gearbox.
Right, okay.
The generator is mounted directly on the bottom of the rotor, really to maximise efficiency, reduce part count, and that gives us a nice sort of mechanical simplicity to the design. And then it's a question of converting that electricity. You get three-phase electricity out of the generator needs to be converted to DC, then back into grid-compatible AC. And we have quite a sophisticated control system which monitors the wind speed and enables the turbine to respond rapidly to changing conditions.
And cost-wise, how does it compare with competitors? Obviously, you've got fewer moving parts, things and such like.
We've still got some work to do on getting our costs down. They're still higher than most of our competitors. We've got plans and ways we're trying to tackle that at the moment.
Is that more to do with design or the manufacturing?
A bit of both. Both.